simplifying radical expression with two variables. Now, if you've got the calculator that I recommended, it makes it a little bit easier because you can punch in the square root of 20 and it'll simplify it for you. If you don't have it, of course, what you have to do is you have to break this down and you have to find multiples that will give you 20, but one of them has to be a perfect square. So in this case, 4 is our perfect square, so 4 times 5. And remember, with radicals, you're ultimately doing the square, meaning 2. So while we don't write the 2 here, there's kind of like this invisible 2 here. So we're always doing groups of 2, if you will. So with our letters here, we can't divide the 7 by 2. It wouldn't work. However, we can separate it. And let's put it as x to the 6 times x, because we learned last week that we would add those exponents together to get us this. Okay, so now I've separated it. I'm going to recopy this y to the 6 here. Okay, so the square root of 4 is 2, so that comes out. And with our letters, remember we have to divide the exponents by 2. So 6 divided by 2 gets us 3. So x to the 3rd comes out. We're going to take the y, and we're going to divide that exponent by 2. So 6 divided by 2 again is 3. So we've got y to the 3rd. Okay, all of that comes out of the radical. So now underneath the radical, let me kind of change colors so that way we can see. See, we took, this came out, and this came out, and this came out. So what we have left is we've got 5x that's still underneath the radical. Okay, and this would be the answer that you'll be putting into ALEKS. Now, as you're entering it into ALEKS, it's very important that as you're typing this, you do 2x cubed, press the right arrow key on your keyboard, okay, to space it over. Y cubed, again, press the right arrow key to space over, because otherwise it's real easy to put that radical up here with the 3, and of course ALEKS will mark it wrong because this isn't part of the exponent. Okay, so make sure that you're hitting those right arrow keys in between in order to get the correct answer when you punch this in. Another way that you can look at it is we can break this down, and of course we'll kind of do this with the higher roots. So we'll go ahead and show you an example here. Now again, remember this is groups of 2. I'm going to kind of squiggle a 2 right here. Okay, so if we broke this down, we did 2 and 10 and 2 and 5. Okay, so for every group of 2, so every group of 2 in this case, 1 comes out. Okay, so here's one group of 2, so I write a 2. Now, this is the same problem, we're just kind of looking at it from a different angle. Okay, so with this x to the 7th, what we can do is we can break this apart. So we got x, 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 x. There we go. So I got 7 x's here. So for every group, we've got one group of 2, 2 groups of 2, 3 groups of 2. So we got x to the 3rd. See how that worked? And then same thing with their y's. We can break these down. And so here's one group, 2, 3. So it's y to the 3rd. We put a radical, and then we put whatever's left over. So in this case, and you have to pay attention, this last 5 seems to always be forgotten if you do it this way. And then of course we've got this lonely x here. So whether you do it this way or you do it that way, notice you'll get the exact same answer. Again, be careful as you're entering it into ALEKS and press that right arrow key on your keyboard, so that way you're not accidentally typing something else into the exponent box.